Congrats, guys, you have made it to the very last lesson of Unit 2. It's going to be what we call sequences. It feels a little different, it works a little different, it's got new notation, but bear in mind as we go through this lesson and these examples that it really is just another way of talking about linear equations, which by this point you guys should be so good at that this doesn't even cause a bit of a problem. All right, let's go ahead and get to it. All right, guys, welcome to this last lesson of Unit 2. For this lesson, we're going to step away from the systems of equations just a little bit and talk about arithmetic sequences instead. So they still fit with the same overall theme of Units 1 and 2, where we were dealing primarily with linear equations, but these look a little bit different. We use a little bit of different notation. We talk about them a bit differently. So let's go ahead and get into some notes and I'll show you what I'm talking about. So this is saying I understand that sequences are a function with a domain of integers. Now we haven't talked a lot about domain. That's going to be in the next unit. But basically that means what numbers are you allowed to plug in? And typically we've done problems where I can plug in whatever x I feel like plugging in. Positive, negative, decimals, fractions, it doesn't matter. But in these, they have to be integers. And actually that's not even true. They're not going to be integers. They're going to be the natural numbers. So you can fix that. Natural numbers are your counting numbers, 1, 2, 3, 4, 5, and so on. So the domain of an arithmetic sequence is just the natural numbers. Those are the only numbers you're going to be plugging into these. So let's go ahead and say a sequence is an ordered list of numbers. Now, it can also be a list of pictures, letters, figures, anything you want, but this is math class, so we're going to be focusing on lists of numbers, and they are in a nice pretty order. Each number in the sequence is going to be called a term. We've seen that word before. This is a slightly different meaning, but basically it's just the numbers in the sequence or in the pattern. We usually separate them with commas because, you know, that's what we do with lists in the English language. We can also think of a sequence as a function whose input consists of the consecutive natural numbers. Remember, consecutive means one right after the other. Natural numbers, like I said before, those are just your counting numbers. With sequences, we use sequence notation. And here, instead of f of x or g of x or y's and x's, you're going to see a's and n's. So a sub 1, a sub 2, a sub 3, where a sub 1, that's how we read that little 1 there, represents the first term in the sequence. So if you have your pattern laid out, the first number in the pattern is a sub 1. A sub 2 is the second term in the sequence. And then a sub n is going to be some nth term, meaning some term in the future that we haven't decided yet. That's kind of similar to saying f of x. It's some term that we don't know the value of right now. A sub n minus 1 is an interesting one. It represents the previous term. So if you're looking at a pattern and you want to know some future a sub n minus 1 refers to the number right before it in the pattern. The subscript, this little sub value here, is called the index, and that just refers to the term number. So the index here is 1, the index in this term is 2 and 3, and so on. So in an arithmetic sequence, there's some common number that we refer to as the common difference, and we use the variable d to represent that for difference. This common difference is added to each term to get to the next term in the sequence. So let me show you what I'm talking about here. We have a sequence of numbers that are in a pattern. They're in a specific order. You can see that to get from this first term to the second term, I'm adding 5. To get from here to here, I'm adding 5 and 5 and 5. So that means this is an arithmetic sequence with a common difference of 5. If I wanted to say this would be a sub 1, that's the first term, this would be a sub 2, a sub 3, a sub 4, and a sub 5. Right? This one, I'm adding 4, and then here I'm adding 8. and then here I'm adding 16, and here I'm adding 32. If you're not sure how much you're adding, just subtract. 64 minus 32 is 32. So because I don't have the same number being added each time, this is not arithmetic. So we wouldn't really deal with that in this unit right now. All right, you guys go ahead and look at these three, see if they are arithmetic or not, and if they are, tell me the common difference. And I'll see you on the other side.